this is going to be the scientific notation and how to use it video. So what is scientific notation? Basically, it's just another method of writing really, really big and really, really small numbers in a far easier way than writing it out longhand. And you can kind of see that with this example right here. We have Avogadro's number, which is unfathomably large. And personally, I would not want to write this out longhand every single time and try to worry about how many zeros there were. I would much rather write it in scientific notation. It's quicker, it's easier. That's the whole point of scientific notation. There's a couple of rules. First, if you're going to write something in proper scientific notation, the coefficient value, and that's this regular looking number in front, that has to be somewhere between 1 and 9.9. It can't be 900 or 7,000 or whatever, because that's considered improper scientific notation. So that means that this number, 9.0 times 10 to the third, is proper scientific notation. Whereas if we were to write the same exact number as 90.0 times 10 to the second, that would be improper scientific notation. Technically, both of these values represent the exact same number. However, this one is considered proper form, whereas this one is considered improper. The second rule is that the sign, either positive or negative, of the exponent value indicates if that number is big or small. So again, the exponent value that I'm talking about would be this one right here. So if that exponent happens to be positive, that means that you are looking at a larger number. If that exponent value is negative, that means you are looking at a smaller number. So, how do you move from a number in scientific notation to a number in standard form? Well, that's pretty easy. All you do is you take the regular looking number, the coefficient value, 3.4, and you take the exponent value, and the exponent is going to tell you how many places to move your decimal point. So in the number 3.4 times 10 to the third, we are going to end up moving our decimal point 3 places. So here's where the decimal is starting out. This exponent is a positive value, so I'm going to move my decimal point in the direction that makes that number bigger. I'm going to move it 3 spaces to the right. 1, 2, 3. And I'm going to put it right there. Any of those empty spaces, I'm going to fill with zeros. So my number in standard form is 3,400. If my exponent value was negative, that means I'm going to move my decimal point the opposite direction, but I'm still going to take that regular looking coefficient value, 3.4. But this time, since my exponent is negative, I'm going to move that decimal point 3 spaces in a direction that makes my number smaller. So in this case, to the left. Whoops. I'm going to move it 1, 2, 3 spaces to the left, and I'm going to fill those empty spaces with zeros, just like before. So my new number would be 0.0034. How do we do the opposite thing? How do we move from standard form into scientific notation? Well, we're going to go the exact opposite direction. So we find my decimal point, which is in this case inferred for the number 45,000. Remembering that to write a number in scientific notation, I need to end up with a coefficient value that is somewhere between 1 and 9.9. So I'm going to move my decimal point to the left in this case. I'm going to move it 1, 2, 3, 4 spaces to the left, and I'm going to end up with 4.5. Since I moved that decimal point 4 spaces, that means that my exponent value is 4. I know that it is a positive 4 because this is a large number, so therefore my exponent should be positive. All right? For this second number, 0.000045, I'm again going to shoot for a number that is somewhere between 1 and 9.9. So in this case, I'm going to move my decimal point to the right. I'm going to move it 1, 2, 3, 4, 5 spaces to the right. So I again end up with the number 4.5, but this time my exponent value is -5 because I've moved that decimal point 5 spaces, and this is a very small number. So my exponent value should be negative. When should you use scientific notation? Use it when it makes sense. It is not something that you have to do for every single number in this class. In fact, if you write every single number in this class in scientific notation just to say you did, I'm going to judge you a little bit in a friendly way. So if you see a number that you can easily write in standard form like this one, don't bother writing it in scientific notation. Writing this as 6.01 times 10 to the second is useless. Why? Why would you do that? You don't need to. The number 601 is perfectly understandable as it is, so it's unnecessary. However, if you're looking at this number and that is your answer, it is in fact probably going to be easier for you to write that number in scientific notation rather than counting all of those zeros out. So instead, I would write that number 6.4 times 10 to the 3, 6, 9, 12, 13th. That's in fact going to be an easier number to work with and an easier number to write out than this one would be. All right. The third reason that you could use scientific notation is if you have to round for a specific amount of significant figures, but your answer is making it really hard to round for that amount of sig figs. So the example I have for you is this. Say your answer is 130,000. You don't necessarily need to write that in scientific notation. However, you know that you need to round that number for 3 significant figures because of the problem. But the issue with that is that this number has 2 significant figures, and there's really not a way to round it for 3. But you can do it by writing it in scientific notation, because I can also write that number 1.30 times 10 to the 5th. And in that way, I've created a number with 3 significant figures, because if we were to just look at 1.30 and evaluate it for sig figs, you would say that there are 3 sig figs in that number. And we have accounted for the magnitude of the number by writing it in scientific notation. So that can be another reason to write things in that notation. Now, in terms of math in scientific notation, we're going to use a ton of numbers in this class that involve doing math with numbers in scientific notation. So if you have a calculator that makes it really easy for you to just plug that in, great, do it, amazing. Graphing calculators in particular are really, really good at doing math with numbers in scientific notation. You just have to know how to use your parentheses. But if you don't have a graphing calculator and instead you have one of the smaller, little cheaper calculators like the ones on my wall, it might actually be easier for you not to plug it into the calculator. I can show you how to use those calculators effectively, but if that's hard for you, if figuring out how to plug things in that type of calculator is difficult, you might want to use these little tricks. If you are adding and subtracting numbers in scientific notation, those numbers, unless you're doing this on a calculator, have to be the same magnitude, because you can't just add these two numbers together. You can see that their magnitudes, their exponent values are different. So we can't just straight add them together. And the reason you can't do that is because if I write these numbers out longhand, you'll see that their place values are very different. 6.0 times 10 to the second is 600. And 7.0 times 10 to the fourth is this. So if you're going to add those two together, you have to pay very close attention to their place values. You can't just add 6 and 7 and hope for the best, right? Because this would actually be this number, okay? But if you convert them to match each other, like over here, so that their place values match, you can actually do this really, really easily. You can add these two numbers, 706, and get 706, and you can just keep the exponent value the same. Because if you write that longhand, you're going to end up getting the same answer as over here. You would get 70600. For multiplication and division, this is what you're going to see the most in this class. It's very rare that you'll have to add numbers in scientific notation or subtract them, but you're going to have to multiply and divide them a lot. And so there's a little bit of a shortcut if you're doing that. If you're multiplying two numbers in scientific notation, you need to multiply the regular looking numbers, the coefficients, and you're going to add the exponents. So let me show you. Here's the regular looking numbers that we're going to multiply. 5 times 6 is 30. And then we're going to add these two exponent values. Now, we just found an answer really, really quickly and really, really easily. The only thing we have to do is convert it into proper format, because remember, our number, our coefficient value has to be between 1 and 9.9. So I just have to scooch that decimal point over 1 and make it 3.0. Since I made the coefficient value smaller, I'm going to make my exponent bigger by 1 space. And that's my answer. If I'm dividing, I'm going to do the exact opposite thing. I am going to divide my coefficient values and I'm going to subtract my exponents. So in this case, we're going to divide these regular looking numbers right here. 6 divided by 2 is 3. And then I'm going to subtract my exponents. Now you need to be careful when you're doing this because sometimes you're subtracting a negative value. And this is one of the errors I see all the time. People are like, all right, 3 minus negative 3, 0. No, it is not. 3 minus negative 3 is in fact 6. And if you need help figuring out how to subtract negative numbers, I'm happy to go over that with you separately. But once again, by using this trick, we just very easily divided these numbers and we did not have to plug anything into a calculator or worry about parentheses or anything like that. So if you're having any trouble with any of this, please see me in class. I'm happy to go over this with you separately.